Hi, it's time for another math easy solution. Today we're going to discuss an example on integrals and go over the trigonometric integral from my earlier video, polar coordinates, arc length, example 1 video. So basically recall from my earlier video titled polar coordinates, arc length, example 1 that I used an online integral calculator to solve the following trigonometric integral just to save time, and it was this one right here. Integral from 0 to 2 pi of square root 2 plus 2 sine x dx, and then it equals to, well, this is the indefinite integral like that. This is from 0 to 2 pi. And I just want to make a brief note here as I solved this manually. This is actually not accurate right here. Yeah, not accurate. I'll just write misleading, and the reason is when you try to evaluate this integral, there's a problem because there's a square root here, so it always needs to be positive. But then when you solve the integral manually, you'll see that you'll end up with functions that could be positive or negative, such as the sine. So you need to be careful of these intervals from 0 to 2 pi, and this will make more sense as I get through this video. So basically, then they use an approximation method, the calculator, and gets 7.999. It's basically 8. So the exact answer is 8. So now let's basically solve it manually. That's what the question's asking. So let's jump right in. What I'm going to do first, I'm going to let this whole integral equal to I, just so it's easier to write. Yeah, so let's go and solve this manually. So what I'm going to do is write I equals 2. So that's what we have, was write this down, 0 to 2 pi of square root 2 plus 2 sine x dx. Yeah, so now what I'm going to do is I'm going to factor out the 2. We'll do that right here, like that. 1 plus sine x inside, so that we can take this square root out of there. So this equals to square root 2, and let's take it out of the whole integral, just a constant. So it's the integral from 0 to 2 pi, and now we have 1 plus sine x dx. Yeah, so now that we have this, what we want to do is want to remove this square root. So I'll write want to remove the square, so it's easier to deal with, because right now it's just not clear how to solve this integral. So now one way of trying to remove it is, well, if we recall the trig identity, the half angle one, so I'll write trig identity right here. So if we recall the trig identity, and you could watch the proof in my earlier video, so cos squared x, this equals to 1 plus cosine 2x over 2. Yeah, now here, instead of just writing x, I'm going to change this variable to theta, just so it's easier to deal with it, so that we know that x and theta are different. So now the reason we do this one is if you move this over, you get, well, 2 cosine squared theta equals to 1 plus cosine 2 theta. So now we have this 1 plus 2 theta right there, and then we also have this 1 plus sine x. So we got to convert the cosine to a sine, so that we have this. There's a square root. There's a square there, so that cancels with a square root like that. For example, I'll put this arrow like that. So if we have something like cos squared theta squared, then basically that square root goes away. So we have a cos theta. Yeah, so this is what we want. Want something like that. And now what we have is 1 plus sine x, so we have this 1 plus cosine 2 theta. So what I'll do is I'll write equals to 1 plus sine x. So then now we have to connect the theta with the x. So this is, put a bubble, again, this is also what we want, so that we could just replace it with this 2 cosine squared theta. Now we could just recall the identity to get between cosine and, I'll put this around here so it's separate. Yeah, so now what we'll do is connect the cosine and sine, and that's an easy one to do because we can just recall Yeah, recall, what I'm going to do now is if we just draw in this quadrant an angle like this. So I'll draw this angle. It doesn't matter where it is. So let's say this angle, I'm going to write this as 2 theta just so it connects with this one. Yeah, so now if we have this angle, I will draw a right angle. This is going to be, let's just say this is A, this is B, and that is just the sides of that triangle. So now what we'll do is just draw an opposing triangle like that. So then this angle is going to be, well, this whole thing is pi over 2, or 90 degrees. So we just go pi over 2 minus 2 pi over there. And then we have this B over there, we have A over there. So now what we could do is look at these triangles. So what we know is we want, let's say, this cosine 2 theta. So cosine 2 theta. This is just equal to adjacent over hypotenuse. I'm going to write this as C as the hypotenuse. That just equals to, well, B over C. And now this equals to, now if you look at the other angle, that's just the, B over C is just the sine of this other angle, pi over 2 minus 2 theta. This equals to sine of pi over 2 minus 2 theta, like that. Yeah, so now what this means is, well, we could throw this inside here, and that's our sine. Remove that like that. So that means that x needs to equal to, well, this part right there. So just this will make more sense here. I'm going to put this across here. So that's what we have. Thus, 2 cosine squared theta equals to 1 plus cosine 2 theta, and that's the same thing as there. And I'll just write this as sine pi over 2 minus 2 theta, like that. Yeah, so now this equals to, well, 1 plus sine x if this is equal to x. So if x equals to pi over 2 minus 2 theta, so now what we need to do is solve for theta here in terms of x. So we can move this around. We get, move this across there. Or actually, let's move the positive one there, move the x on the other side. So we get 2 theta equals to pi over 2 minus x. And now we have this theta over there. Yeah, and just divide by 2. So we get theta equals to pi over 4 minus x over 2. Just times it by 2 over 2. So we get a common denominator of 4. This equals 2 pi minus 2x over 4, like that. Yeah, let's put it like that. So that's theta right there. So what this all means is now we have 1 plus sine x over here. This equals to 2 cosine 2 theta, and that's what theta is over here. So thus 1 plus sine x equals to this part right there, which is 2 cosine squared, and now we have this angle pi minus 2x over 4, like that. And then when we square it, we get rid of that square, the square root that we wanted to. Yeah, so let's put this all together. Thus, again, I equals to, scroll up here, the integral is, this is going to be square root 2 integral of 0 to 2 pi of 1 plus sine x. So we have square root 2 integral from 0 to 2 pi of 1 plus, square root 1 plus sine x, which is equal to 2 cosine 2 pi minus 2x all over 4, like that, dx. Yeah, so now that what we have here is, well, this square root and this squared cancels. We're left with, now that's going to be square root 2 times 0 to 2 pi times it by, take this out, square root 2 like that. And now what we have is a cosine of pi minus 2x over 4, like that. Yeah, and then dx here. But there's a problem here, is because this cosine squared is always going to be positive, and then the square root inside needs to be only positive as well. Yeah, so basically this whole thing needs to be the absolute value, so we can't take any negative numbers, And this is, I'll write this, because cosine squared of pi minus 2x over 4 is always greater than or equal to 0 because you're just squaring it. Yeah, so thus we can't have any negative cosines in this integrand. Yeah, now also what I'm going to do is, because notice we have a pi minus 2x over 4, but then the calculator over here had a 2x minus pi over 4. So we're getting close to it. That's just switched around using the property. And just to make it similar to the other one, recall that the cosine function looks something like this. This is x. This is, let's say this is cosine of x on the y one. Looks something like this, etc., where the right and the left are the exact same. So this is just a mirror image of itself. So then this means that while cosine x is just going to equal to cosine negative x. If you go left, it's going to be the exact same thing, it's just a mirror image. If you go right, it's going to be the same exact thing. So you just take a point here, x, it's going to be exactly the same as if you went negative x. Same thing. So that means we can just put a negative across there. So I'll move this down here. Yeah, so then we have I is equal to square root 2. Well, actually, there's a square root 2 and there's another square root 2. I'm just going to put square root 4. So yeah, we just have a square root 4 there, and now we have integral from 0 to 2 pi. And again, it's going to be absolute value of cosine. And now what we're going to do is put a negative inside. So if we put negative of this pi, it's pi minus 2x over 4, all we do is switch this to negative 2x becomes positive, and the pi becomes negative, because remember, this is equal to the exact same thing. So this just equals to 2x minus pi over 4, like that. And I'll put an arrow indicating that we just flipped it around. So then that's absolute value, and then write dx over there. So now what I'm going to do is substitution right here. So I'll put this like this, let u equals to, well, 2x minus pi over 4. And then when we take the derivative, this just equals to, well, 2x over 4 minus pi over 4. That just equals, simplified further, again, x over 2 minus pi over 4, just to take the du. That equals to, well, that is dx over 2. The other one just goes to 0. So we have here dx equals to 2 du like that. That is this part right here. Now we have this. Now we just need to know the intervals. So at theta equals to 0, we have u equals to, actually it's not theta, this is x. So at x equals to 0, we have u equals to 2 times 0. That just goes to 0, so let's write 0 minus pi over 4 just equals to negative pi over 4, like that. And then at x equals to 2 pi, that's the top interval. That's this one right there. That just equals to u equals to 2 times x, which is 2 pi, like that, minus pi over 4. That's just 4 pi. 4 pi minus pi over 4 equals to 3 pi over 4, like that. So then what we end up having is the integral I is equal to, there's a 2 there. This is just 2, yeah, that's just 2, equals to 2. So then what we have is 2 times the integral from 0 to pi changes into negative pi over 4 to 3 pi over 4 of absolute value of cosine u, and then 2 du like that. That's a dx over there, and then we could just simplify this even further by, yeah, we have the 2 there, just remove it, put it in front, times it by 2, we get 4, like that. And now to remove this absolute value sign, what we'll have to do is separate this integral into different intervals. So what we'll do is, well, recall again for the cosine function, Just going to do this like here for u, and this is cosine u for the y. And notice it, remember, it just looks something like this. But now we're going from negative pi over 4 to 3 pi over 4. Remember that this is at pi over 2, and then we have at this point is at pi, that's at bottom negative part. So that's in between there. That's actually right here. That's in between. It's 3/4 of a pi, so 3 pi over 4 like that. So we get a negative there. And so we have a negative value for cosine there. We have a positive here, and then we also have a positive on the negative pi over 4. Remember, this is negative pi over 2, so it's going to be right in between half of that. That is negative pi over 4 like that. So this is positive. So all we're going to be doing is, well, we're going to go from negative pi over 4 to here. That's positive. Then we need to flip this by putting a negative sign to get rid of this absolute value. So what we have is thus if we write this integral down, we're going to go now from integral from negative pi over 4. So we have 4 like that, and then negative 4, and then now to get rid of that absolute value sign. So we go from negative pi over 4. Now we go from here all the way to here because it's always positive, and then we can get rid of the absolute value sign. So that's pi over 2. Now we have cosine u du, and now we subtract because it's going to be negative there, so we just add a negative. There's going to be another 4. This is going from now we go from pi over 2 to 3 pi over 4. So pi over 2 to 3 pi over 4 of cosine u du like that, and we get rid of the absolute value sign because it's going to be negative, and we put a negative there. So when we evaluate this, we get a 4 integral of cosine u is just sine u, and now we have like this integral from negative pi over 4 to pi over 2. Subtract this now by 4, and now the integral of, again, cosine u is just sine u. We go from pi over 2 to 3 pi over 4 like that. And recall u, and now we have 4 sine u is just the indefinite integral. And notice how the u is just equal to 2x minus pi over 4. Yeah, so that means we got the initial part right. Yeah, so this is just cosine, that's just u. So this part right here is just u over there. So we have 4 sine u, or just 2x minus pi over 4. And that's exactly at 2x minus pi over 4. So we got the indefinite integral part correct. But yeah, I believe they should have included the absolute value sign. Yeah, and the integrand should have included that, but I don't think they have an option there. Yeah, I think it's the online calculator. Just I don't know what they did. They don't present it clearly. But their approximation method nonetheless gets the right answer, as we'll show right here. So now if we evaluate this equals to 4. And now integral sine u, we evaluate this, we put sine pi over 2 minus sine negative pi over 4. And now we subtract by 4. Now sine u sine 3 pi over 4 minus sine pi over 2, like that. So now to evaluate this, well, first thing what we could do is recall the exact ratios. We could solve for pi over 2. That is, well, sine curve looks something like this. Let's write this as x. This is as sine x as the y-axis. So for pi over 2, that is actually just here. That's pi over 2. Let's just recall. That's at 1. So then this goes to 1, and this goes to 1 over there. Like that. Let's put a better number there. Like that, and 1. And now to get this sine pi over 4, what we'll do is just draw a quadrant section like this. So now we have this. We'll basically recall that pi over 4 is just 45 degrees. So this is just pi over 4. The full thing is pi over 2. So that's exactly 45 degrees. If we draw a right angle like this is just 1, because it's an exact 45 degrees. So if you draw a square like that, you get a perfect square. Cut this inside. So yeah, so these sides have to be equal 1, 1. etc. So then this angle right here, or this length, that's square root 2, and that's by, well, just Pythagoras. So 1 squared, add up the sides squared, like that. 1 squared plus 1 squared equals 2. Well, that's just equal to 2. Equals to 2, which is, well, the same thing as writing square root 2 squared, where that is just Pythagoras. Pythagoras. Or Pythagorean theorem, like that. So now that we have the basic one there, that's pi over 4, what we'll do is we'll go to the negative side. So if we go to the negative, we get a negative 1 across here. So that's the opposite over hypotenuse is here. So now we have and I'll remove this like that. So this is just negative pi over 4. I'll just put the 1 here for the length, the horizontal length. So that means right here we have sine of negative pi over 4. Remember, this is opposite of our hypotenuse. That's just equals to negative 1 over square root 2, like that. So that's what we have for the this part right there. And now for the 3 pi over 4, remember that 3 pi over 4 is less than pi. So it's going to be somewhere across here. This says, let's draw a full one like this. Let's draw this a bit better. So from here to here, yeah, extended that like that. So now we have here is there, right angle. We have 1 square root 2. This is just pi over 4. So then 3/4 of pi, just 3/4 times pi is this right here, 3 pi over 4, this angle. So that's the same thing as finding the ratio there. Yeah, so we have, 3 pi over 4, just move that over. So that means this sine of this 3 pi over 4 is just going to be opposite over a hypotenuse of this triangle. So that's just 1 over square root 2. So 1 over square root 2, and that's positive. So we have a negative and we have a positive 1 there. Circle this. I'll circle this. So thus we have this part is negative square root 2. This is positive 1 over square root 2, like that. So we have 1 minus negative 1 over square root 2 minus, and then we have this positive, and we have a minus 1. So let's write this all down. Thus I equals to 4 times it by, 4 times, now we have, let's write this down again, 1 minus negative 1 over square root 2, 1 minus negative 1 over square root 2, like that, minus now 4, and now we have positive 1 over square root 2 minus 1. So we have minus 4, now we have positive 1 over square root 2 minus 1, like that. So what we'll have is, let's just factor out the 4, so we have 4 out of there. Now we have 1 plus square root 2, like that. Now we have minus, so we take the 4 out, we have 1 over square root 2 and minus 1 times, we took that out, minus of a negative 1 becomes positive 1, like that. These just cancel, so that cancels, goes to 0, because they're the exact same. 1 over square root 2 minus 1 over square root 2 is just 0. So now we have this equals to 4 times 2, so we have I equals to 8, exactly as expected. Yeah, so there it is. And also, let's put for reference, also note that we had that the integrand, as shown above, 4 sine u equals to, 4 sine, now we have, this was, if I remember correctly, 2x minus pi over 4, like that, as in the integral above. That was just from memory. Let's see if I got that right. I'll have to double check it. 2x minus pi over 4, and then it was 4 sine u. Let's see where that is. 4 sine u, like that. That's exactly as shown above in the calculator. So that is all for today. It's a very tedious example. That's why in my last video I just used an online calculator to save time, because it's just super tedious. But a lot of these stuff can be automated through calculators, which just makes saves a lot of time. And there's that integrand right here, but again, misleading because it needs absolute value beforehand when you're working through it. But nonetheless, our approximation method is still pretty good. It gets the 8. So anyways, that is all for today. Hopefully you learn. Like always, you can download these exact notes in the link below, as well as viewing these exact notes in article format on steemit.com. So make sure to follow me at MES. Anyways, thanks for watching, and stay tuned for another Math Easy solution.